In our last tutorial, we covered order divergence, where we went through accessing and plotting the information to do with Darwin's latency, median order replication latency in the examples case, but essentially the data containing latency and divergence experienced by investors per order, per instrument on the underlying strategy. In this video, we'll cover return divergence and monthly divergence, and these include information about the Darwin's divergence and the Darwin's average and monthly divergence, respectively. In order for us to access this information via Python, we'll go back to the same class, and that class will have an additional function we've titled get return divergence and get monthly divergence, respectively. Again, these functions follow the same structure for two purposes. One, to make this code extensible for you so that you can incorporate it into your existing work or modify it easily to suit your particular needs. And of course, to make this presentation as easy to digest as possible in terms of what the data is, how it's accessed, and any post-processing requirements that we need to put in place in order to use that data correctly for future assessment and analyses. Again, this function has the data type specification as return divergence. Important note here, once again, return divergence needs to be specified and it in correspondence with the file name on the FTP server. So if the Darwin doesn't have that file name, this call to the data type return divergence will fail. And the second thing is that the return divergence also needs to have a corresponding analytics header definition in the analytics headers class variable, which is a dictionary object. So here we notice we have return divergence and monthly divergence specified for you with their header definitions, timestamp, quote, etc., etc. Going back to the function, similar to get order divergence, this will execute a call to get analytics using the Darwin ticker symbol that you've provided in the function call and the data type that you've provided within the function called return divergence. Once we execute this, we will get some data back that needs some post-processing into numeric types. And the data is normally returned in object form. So we'll convert this by making a call to the apply function and passing in pandas.to_numeric, coercing any errors to essentially create a numeric time series out of this. Finally, if we've specified plot as true, then we'll execute df.plot with a title, and that will create this distribution here, this chart where you have two curves, quote and quote, after the application of average divergence superimposed onto one chart for you. In terms of interpretation, this reveals that this particular Darwin, LVS in this case, has a positive average divergence over time compared to its original quote evolution. And that's how you access return divergence data from within the environment. We'll follow the exact same logic to create the get monthly divergence function. We'll pass in monthly divergence. Again, that needs to correspond to the file name on the FTP data repository. And this will again execute a call to get analytics, apply a numeric conversion via pandas, coercing any errors, and return to us the data frame, but it won't be plotting this data in this particular instance. For this, we will execute a call to da.get_monthly divergence, specify the Darwin we're interested in this case LVS, and that will produce for us this data frame where we have average divergence per timestamp as well as the monthly divergence over time. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.